Hi, this is the second video related to slide set 0. So this is going to be an introduction to C++. There's nothing going to be technical about it. It's just to give you an idea of what is C++, how it was created, kind of a history of evolution of C++, and things like this. So let me bring the presentation. So this is the history, the features, and the goals of C++. Why is this significant language? And this gives you some brief introduction or pointers as to what tools you can use. For example, different IDEs, depending on what platform you're using. Are you a Mac person? Are you a Windows person? There's plenty of different tools that you can use to develop C++ code. So, So this C++ language was created by this man here named Stu Stop. So he essentially initially created that as a tool for himself as he was doing his PhD research. So he had his own agenda in mind as he was creating this language, but of course it has become now something that is used worldwide by millions of people. So it has become something that is much bigger than what he actually intended in the beginning, even though he had implemented most of it before it went public, and that whole team of people were responsible for its development eventually. So what kind of programming language is, or C++ is? It's a statically typed language. Now, what that means is that statically generally means that the analysis is actually done at compile time before the execution. You have some other languages which are dynamically typed. So that means the type checking is done at runtime. So C++ is statically typed. So that's explaining that explains why in a C++ program, you have a lot of the code that is about types. So when you declare a variable, you declare what type is variable. When you declare a function, you declare what's the type of the parameters and what's the return type. And all this typing information is used at compile time to figure out if the program is type correct. So that if you define a function that receives an int and you try to call it with a string, then the compiler will tell you the types are incompatible at compile time before you execute the code. If a language would be dynamically typed and the types would not appear in the code, then the only way to check if the program is typed correct is to execute the code, which can be problematic because the only way you would figure out if the program is correct is to actually run it. So that, of course, has some problems with the robustness of the programs that you are developing. So it's not good if you need absolutely robust programs to have the possibility that the code fails on type checking because the code was statically type checking of the code, or the typing of the code was incorrect from the start. So that's one reason why C++ was designed as statically typed, so that you can check the typing of the code before you execute the code. It's also a multi-paradigm programming language, so it's a procedural programming language such as C, its ancestor was or is, but it's also a object-oriented programming language. Most object-oriented programming languages are also procedural, but there's also functional programming languages that are also object-oriented. So C++ is procedural and object-oriented. It's a compiled language as opposed to an interpreted language. So you have a compiler that does all kinds of checking, generates code, and then you have an executable, and then you execute the code. For example, if you run your Java code, yes, it's compiled, but what is executed is some kind of intermediate code or your bytecode. For C++, what is executed is directly executable code that runs on your processor, whereby if you are compiling your Java code, it compiles it into bytecode, which is then interpreted by an interpreter, which is your Java virtual machine. C++ is strictly a compiled language. It's also a general purpose programming language. There are literally thousands of programming languages. Many of them actually have very specific purposes. C++ was designed so that you can use it to implement literally any kind of program that you may want for any kind of purpose. Okay. It is very often used for programs that need to be very low level, but it's not the only thing that it was designed for. C++ is actually used as a high-level programming language by using classes and so on and so forth. So it is a general purpose. It was designed as a general purpose programming language. It is also a middle level programming language. So it is the direct ancestor of C++ is the C language. So some of you may have used C and you realize that it's actually quite a low level language. There's not much difference when you understand C. There's not much difference between C and assembly. Okay, when you understand what are your variables and pointers and so on, if you understand what is assembly language, you realize that it's very close. It provides you with a layer of abstraction above assembly, but you can't say that C is a high-level programming language. It provides you with a lot of abstraction mechanisms and so on. So essentially, beyond Stu Stop's design, Stu Stop designed C++ as a layer above in terms of abstraction possibilities, a layer above C++. So that's why it can be called a middle-level programming language, as opposed to low-level, which, for example, is assembly language, high level, which provides you with abstraction mechanisms such as classes, exceptions, and all kinds of things which enable you to express things more abstractly that relate to concepts in the real life. If you're programming in assembly language, you don't have any abstraction level. So by having abstraction level, it enables you to design programs that are much more understandable and that more relate to abstract concepts that you see in the real world. So that's why, generally speaking, what you want is high level of abstraction. However, it comes at a cost. The more higher level abstraction you have, generally speaking, the less performance you will have when you execute the code, or generally speaking, a more higher level programming language will consume memory and will somehow run slower. If you compare two programs that do the same thing, the one implemented in lower level abstraction is probably running faster and consuming less memory than the one that designed in a programming language that is of higher level. That's why it's important to understand what is low level, high level. C++ is one of those languages that has both low level and some kind of higher level of abstraction. So Stu Stop actually designed this language starting in 1979 when he was a student or where he was working at Bell Laboratories. There's a lot of things in terms of programming languages that were invented at this Bell Laboratories. I believe it was in New Jersey in the United States. So essentially he was doing, well, not to go into all the details, but he was working on, remote processing or distributed processing or networking applications and so on. So he was using the language C, which was also designed in Bell Labs. But then he also knew about a language named Simula, which was one of the first, or if not the first, object-oriented programming language. And he knew that from his studies, and he was acquainted with this Simula language. And then he thought, maybe I can design a new language that is actually C, but with the notion of classes and objects. So that's how it started. This whole notion of C++ started in his mind. So if you know, Stu Stop is a very principled person. So he had actually principles in mind as he was designing, as he was starting to design C++, and as C++ evolved as it was under his control. So for a number of years, C++ was under his control and he was the main designer, but eventually as it became public and so on, a lot of people took it over and it became, I would say, something else, even though it kept his the principles that Stu Stop had laid out. So his principles were that it should be statically typed, general purpose, and it should be as efficient and as portable as C. Nowadays, you might say, well, C was or is not very portable if you compare it with other languages that we have now, such as Java. But at the time where C++ was designed, C was considered a very portable language because you had many compilers that were available for a lot of different computers. Literally any computer that you had a C compiler. So that made it C being very portable. So that was the main goals. But eventually he also added some other features in the language, for example, like generic programming in the form of templates. And of course, it added this notion of classes using object-oriented programming. By using classes, it provided data abstraction, but it's also procedural programming. So generic programming, object-oriented, procedural. So that's basically, you can say it's a multiple paradigm kind of programming language, even though its main paradigm is object orientation and procedural programming, or the procedural flavor of object orientation. One of the things about C++ is that it gives you a lot of choice. It gives you a lot of different ways of doing things. It's a very flexible language, but as some of you may know, when you're given different ways of doing things, it does not necessarily mean that all these ways of doing things are the best way to do things. So it gives a lot of choice to the programmers, though it does not control whether these choices are made correctly, are used correctly by the programmer. So it's very easy to design a C++ program, think that you are right, and then eventually realize that you were wrong. Okay, so that's one of the main characteristics of C++. It gives you a lot of possibilities, but also gives you a lot of ways of doing things wrong. That's one of the goals of actually this course, is to teach you how to do things right with C++. Not that this is the only way to do things, but there are some principles that you can use to use it correctly. Okay. Another principle is that it should be as compatible with C as possible. So basically what you wanted to have is the C language added with these, this layer of abstraction that allows you to use classes. So basically, initially C++ was called actually C with classes. Okay, so he wanted, this is C and added with certain layer of abstraction. One of the other principles of C++ is that you should avoid features that are platform specific. A lot of languages are designed on top of a certain platform. Okay, so one of the goals of C++, which was the goal of C also, is to design a language that enables you to write a program, and independently on which computer you are executing this program, it would be meaningful across different computers. Okay, so it may seem that many languages are using this feature, are designed according to this principle, but not necessarily. But this is, for Stu Stop, this was a very important feature. Then for each of the features that you had, that you add to the language should not induce overhead if they are not used. So for example, if you design a C++ program and it does not use, for example, if it does not use abstract classes and polymorphism explicitly, then it should not actually make it so that as you execute the program, that it has an elaborated mechanism to deal with polymorphism as you execute a program that does not use polymorphism. Okay, so that's one of the things that separates it from C++ from Java. For example, in Java, even though your program does not use polymorphism explicitly, it always has this mechanism in place at runtime so as to enable polymorphism, even though it's not used. In C++, that's not the case. That's one of the things we'll see later. So if you design nice features, if you don't use these features, it should not include the mechanism to deal with these features at runtime. Very important, because one of the basic principles of C and C++ is efficiency, so that you should be able to design programs that are as lean as possible so that they run faster and consume a lesser amount of memory. For those of you who know your Java programming, or comparatively how Java compares with other languages, Java consumes a lot of memory. As you compile your program and you start the JVM is a very heavy program. Even though it executes a tiny program, JVM takes a lot of memory. It's not the case for a C++ program. And it should also function without a sophisticated programming environment. Probably what he had in mind with regard to this was comparing to Smalltalk programming language. For those of you who know that, Smalltalk was a very hot language in research in the 1970s and 80s. He used a very nice IDE, but also a very heavy IDE, and it required that you use this IDE in order to develop and run programs. So when you develop a C or C++ program, all you need is to have a compiler, and you don't need anything to actually execute this program. Again, this is to have more portable way of developing programs and executing your programs, and make it so that when you execute the programs, it does not require a heavy environment for execution. Again, the idea is that you want your programs to be as lean as possible, even the development process to be as lean as possible. So the main goals of C++ were to augment C with the notion of classes and inheritance. Keep the same performance as C and keep the same applicability as C. Essentially, you wanted to have the C language with some abstraction levels that allows you to use it more smoothly for more applications, and not do away with some of the things that C was meant to be able to tackle with. That's why eventually it came to be called C++, where the plus operator is the increment operator. So basically, what is C++? It's an increment to C. So again, started in 1979. So he was actually working on his PhD thesis, doing some programming to implement some part of what he was showing or demonstrating in his PhD thesis. And he realized that C was probably not a good tool to do what he wanted to do. So he proceeded in designing his own language. And working in Bell Labs, a lot of people were language designers, so naturally it came about. So he took his knowledge of Simula and classes and object-oriented programming and kind of merged it with the C language. So this actually resulted in a general purpose, fast, portable, and eventually widely used programming language. So you might think that Java made object-oriented programming widespread. It's actually C++ that made it, that showed really to people, practical people, that object-oriented programming can be used to solve real problems. There were other languages before that were doing object-oriented programming or implementing object-oriented programming, or object orientation, but they were not as much used in the industry to solve real problems, you might say. Okay, so C++ is not the first object-oriented programming language, but it's one of those languages, or if not the language, that made object-oriented programming popular. In fact, when Java was created, it was very, very much inspired by the nature of C++, whereas Java actually tried to do away with some of the perceived problems with C++. For example, the difficulty of dealing with memory allocation was dealt with in Java by having a garbage collector and all those kinds of nice things that are very nice things to have, but also incur some overhead as you execute the programs. There are also other programming languages that were used as inspiration as Stu Stop was designing C++ over the years. Similar, there was Algol, of course. For those of you who know the history of programming languages, Algol was a language that was designed in I would say late 1960s. That was one of the first languages that was using what we call now procedural programming. You know, where you have procedures and data structures and so on. Algol was a precursor of this way of thinking. Okay, so many, if not all, of the languages that we know today are actually inspired by Algol. It was also influenced by Ada. Ada was one of the first languages that used, that implemented in a nice way, notion of generic programming or templates. Also the language CLU, which was one of the first, not the first, but one of the first languages using exception handling, also templates. And then later on, some other features were added to C++, like lambda expressions, which was influenced by the ML programming language. So there was a lot of things, lots of influences onto the design of the C++ language. So here I'm showing early history of C++. So in the 1980s, very early 1980s, Stu Stop started doing type checking, implementing type checking in the compiler, much as what was done with C. But as soon as you start adding classes, the type checking becomes something different. Not different, but something more. As soon as you start having inheritance, particularly, or even multiple inheritance, type checking becomes more complex than if you don't have it. The added notion of classes, of course. With classes go inheritance. Not necessarily, though. Some people think that object orientation necessitates to have inheritance. You have some object-oriented programming languages that don't have inheritance. It's not necessary to have inheritance in order to say you have object orientation. Then public and private members, our access modifiers, constructors and destructors, and the probably infamous friend classes, which we'll cover later. Then he added notion of inline functions, default function parameters, overloading assignment operators, and operator overloading in general. So basically, at this point, he named it C with classes. And then came other evolutions like adding virtual methods, dynamic binding, and so on, for polymorphism, method and operator overloading, reference types. So essentially, here you see that C++ was not created. It's not that it was created, somebody sat down and said, okay, here's all that we will have in this language. No, it basically says, okay, I would like to have this, and then implemented this, and then read a few papers or look at other languages and, oh, maybe it would be nice to have this. Let's add this to the language. It's basically adding upon the language that was already there. Okay, so it's not designed in one iteration. That's one of the things that makes C++ kind of weird. It's like a bit of a Frankenstein monster. Is the core of the language, and then you graft things upon it. It may seem awkward to some people that are more purists. Okay. And that's the reason explaining why it is so, because it was designed over time, not in a single shot. Now, that's one reason to explain it, but that's okay. So let's go with well, very early, actually, 5 or 6 years after he started working on it, it actually went commercial. So that's actually where other people started to take over the evolution of C++. So I'm not going to go into all the details here, but you see that there's a lot of things that were added or revised later on as the language was being developed up to the 1990s. Then, as this language became very well used by the industry, of course, a lot of people, and because these people that were designing these versions, some of them actually went in a certain direction, which made it so that you had different compilers going in this way. And then if you take this program that was designed by this compiler and you try to compile it with this other compiler, then it doesn't work, because each of these languages have a different understanding. If each of these versions of the language have different understanding of what's the meaning of the features. So it was difficult for people to, have meaning, a common understanding of what's the meaning of the language. So that's why at some point when something is used in the industry, you need standards, so that when you design a C++ program using a certain feature, it actually has a standard meaning. Okay. So that's why you have a whole series of standards that were designed starting in 1998 and up to the latest standard, which is C++20, which is still in progress. If you want to have some more good understanding of the evolution of these, maybe you can go on the internet and in the preceding slides, in the first part of this slide set, you will find a series of links to the description of each of the the evolution of the C++ language, the official language description that you are able to find on the internet. And it very accurately defines for a certain feature how it was implemented in each of these different standards, and how new features were added and when and so on. Okay. Not that it's actually very important to know, but you have to understand sometimes you would be dealing with legacy code that was designed with a specific standard in mind. And if you try to compile it with a newer compiler, then it might actually not work in the same way, or flatly will not compile. Okay, so you have different versions of C++. It's important to understand differences between them eventually as you deal with legacy code. So we'll not deal with that. We'll try as much as possible to not have to deal with that in this course. for example, I'm not going to ask you questions in the exam about what is valid in this standard and what's not valid and things like this. Okay, never will we discuss about that kind of thing. Not that it's not important. So what is the positive and negative aspects of C++? It's a general, first positive, general purpose language. So literally, if you have a problem in mind, you want to implement something, you can do it in C++. Okay. There's very few things which you have in mind for which C++ would not be it would not be possible to use C++. Maybe it's not appropriate, but it should be possible to design almost anything, to implement almost anything in C++, which is not true of any programming language. So its implementation focuses on high performance and lean runtime system. So that's if you want to have something that has to run on a computer, let's say an embedded processor that has very limited amount of memory or processing power, then C++ is a good candidate. If you are even more restricted, maybe C++ is even too bloated, I might say. Sometimes when you have to design something on a very limited processor, you have to go much more lower level. Okay, but in general, C++ is very well adapted to run on platforms that have limited resources. Though you have to be careful on what features of C++ you use, as we will discuss later. It provides both high-level abstraction and low-level programming features. So it's a very versatile kind of language. Yes, it is very low-level. If you understand how it works, really, you understand that it's very low-level, but it provides you with features that enable you to reason or design at a higher level of abstraction. This is providing with a lot of flexibility. And the tools that you have are very popular. So popularity is something that is very difficult to define, but here what I mean by popularity is that there's a lot of people that are using it, okay, in real life. Okay. So in the course, in the labs, we will use Visual Studio. So the latest version is 2019. That's something that is widely used in the industry. There's also the GCC compiler that is available on literally any platform that you may find. So there's a lot of tools that are available for you to develop code in C++. Other languages are much more restricted. C++ has a lot of diversity in the tools that you can use. As for the negative aspects, it's well, comparatively to other languages, it's a very large and complex language. As I said earlier, there were a lot of things that were added onto C++. If you want to understand everything, it's very large and complex, okay? Especially when you start digging into the details, it is a very complex language. And, you know, it's not like sometimes you can, if you use Java, for example, you can use Java without necessarily have to understand what's happening behind the scenes. You cannot do that with C++. You can try to use C++ as you were using Java, but very soon you're going to come into troubles, and then you're going to see that in order to understand or to fix the problems that you have, you're going to have to understand the complexity of how the language is implemented. That's one of the things that is nice about Java. It kind of shields the programmer from having to know how it's actually executed. For C++, this shielding is very, very thin, okay? Very soon you will realize that you're coming to troubles, and then if you want to find your way out of troubles, the only way is to open the hood and then see, okay, what's really happening here, okay? In a way, because of that reason, it also is a very good thing to know about C++ because it forces you to understand how things are, what's the meaning of the programs that you are writing. Okay. In a way, being a good C++ programmer makes you a much better Java programmer. But sometimes some Java programmers that don't really understand things, when they start using C++, they're like, oh my God, what is it? I thought I was good, but apparently I'm not. That's something that frequently happens to some people that are good in Java and try to learn C++. You have to understand this is not a bad thing. It is eventually going to be good for you to have to understand how it works. So it's going to make you a better programmer. To the process of mastering C++ is going to make you a much better programmer. Kind of negative aspects. Some of the higher level of abstraction that C++ provides also comes with some detrimental performance issues. So for example, if you are using the standard template library or STL containers, they are very nice features to have, but their high level of abstraction also comes with a cost of consuming more memory and run a little bit slower. Okay, so you have to be aware of what compromises that you are making when you use these things. So I was talking about earlier about popularity. So what is it that made C++ popular, or why is it that C++ is popular? Again, by popular, I mean that it's used by a lot of people. Like, for example, you might say, for music, for example, what makes music popular? It's not necessarily the quality of the music. Sometimes you have music that is very popular and it arguably of not so high quality. It might be catchy, but you soon realize, it gets out of style very fast. So here, when I talk about popularity, it's basically how many people are using it, how many lines of codes are written in this language. So that's what I mean here by popularity. So what are the factors? First, C++ is a superset of C. But you have to understand that the C language in the 1970s and 80s was probably the main computer programming language. Like operating systems were developed using C, and operating systems is the basis of a computer system. So it was designed as being compatible with C, being a superset of C. So what that means, being a superset, is basically that when you have your C++ compiler, you are able to compile a C program. So a C program is a valid C++ program. That's what's meaning of a superset. There are some it's not entirely true for the purists, but that's the general concept. So the idea was that there were all these programs that were designed in the 1970s and 80s. All these legacy programs were already there, and then somebody designed another language that was basically a superset of this other language. So basically, if you compare the lines of code that you can compile using your C++ compiler, that includes the C programs. That makes this C++ include somehow the popularity of C. C++ was designed for performance similar with C. Most of the arguments that you will, if you discuss programming languages with people, people that like C will always talk about performance. And of course, performance is very important if you design, for example, your operating system or device drivers. The performance is foremost. Okay, that's the most important feature of the program that you will design. If you, for example, design a video card driver, it has to have very high performance. So performance is something that is very valuable for a lot of people, and rightly so. It's not necessarily always important to have high performance, but for a very large number of code that you develop or programs that you develop, it is very important. So C++ was designed for performance. So that's one of the reasons why it's popular. You have a very great number of C++ compilers available, literally for any computer you can imagine, or device that you can imagine, electronic device, you have eventually a C++ compiler for this device. So of course that contributes to make C++ popular, because no matter what device that you are thinking of developing an application for or a driver for, then you have the possibility of using C++, which is not the case for many of the other languages. C++ was the first object-oriented programming language suitable for the implementation of large commercial software. That's what I was saying before. It's not the first object-oriented programming language. It is not, but it is the first language that was used to develop commercial, large-scale commercial software in an object-oriented way. And eventually, for example, nowadays, if you ask programmers and they say, what is programming? They'll probably add the notion of classes and methods and polymorphism into their narrative. It has become that programming is kind of inseparable from object-oriented programming nowadays. Not that I agree with this statement of what is programming, but that is what many people think. So that contributes to the popularity of C++ being an object-oriented programming language. Wide array of C++ libraries are available. So there's literally thousands upon thousands of different libraries that are available for C++. I have to understand that libraries are code that you can reuse. And it's basically code that was designed by another person that you can use to actually leverage and be able to do something that you want to do, and very quickly, okay? So the more you have libraries available for a language, then the more people know about these libraries, and the more these libraries are good, the more it allows people to efficiently be developing more code, more easily. So the more a language has libraries, the more it's powerful, the more people will use it. Okay, so that's C++ is one of the languages that has the most libraries. There are others. For example, Python is known for having also a huge number of libraries. C++ is one of those. Last but not least, what is, again, that comes to talk about popularity. Popularity is how many people are using a language, or how many lines of code have been written in this language. Because the more lines of code there are that they are executing currently in computers worldwide, let's face it, you have to maintain these lines of code. You have to deal with them. You have to make them do something else. So when you design something new, very often you have to take something that's already there and make it do something more. You're not designing from scratch everything that you are designing. You're very often reusing something that already exists. So the more there are lines of code in a certain language that exists, the more people are going to reuse or have to use these existing lines of code, and thus create more code. So the more code there is, the more code there will be. That's basically kind of a snowball effect of code use. There are other languages that are not even used nowadays, like, for example, COBOL. There's like billions of lines of code of COBOL that are executing in your banking system every day that you use a banking system. You are eventually you don't know, but you are executing lines of COBOL code down the line to do your banking transaction. Why is it still there? Because it works. Okay, so you might know from the news sometimes or on Twitter that people are looking for COBOL programmers, and people are like, what are you talking about? This is antiquated. Yes, but it's still there and people have to deal with it. It works. You don't have to redesign it. It just works. So the more lines of code there are, the more it stays there and needs to be updated. That is also what is popularity of programming language. And you see that this is not a, here popularity is not a judgment as to how good a programming language is. Very arguably, you could say, you could argue very adamantly that COBOL is an atrocious programming language, but yet it is still used. So it is still popular because it's there. So other significance, so C++ is widely used in the software industry. So the more it is used again, the more people trust it and have to deal with it because it's there, the more it becomes something that you have to deal with. So in terms of usage, if you count the number of lines of code that are currently being executed on all the computers worldwide, C++ is on the top of the list. There are also key areas of software development that rely almost entirely on C++. For example, system software, device drivers, embedded systems, high performance client-server applications, audio and video processing, the film industry, video games. All these are almost exclusively using C++. Again, I'm saying here almost. I don't mean that C++ is the only thing you can use, but again, for example, for video processing, most of the programs would be using C++. Okay, so here we go with tools. So which tool are you to use? There's a lot of different tools that you can use to develop C++ code. Here I'm just giving you a list. This is a very limited list. I'm not saying these are the best. These are the ones that I know that are good and that a lot of people are using them. So for example, if you're an Apple person, then Xcode is a very popular choice. If you are a Windows person, there's a lot of different solutions available. What we will use in the labs is Microsoft Visual C++. That does not mean that it's the best, it's just the one that we use. Or you might also want to use Eclipse for C++. It's also very popular. And of course, you have the people that are here, when we talk about Microsoft Visual C++ and Xcode, these are very elaborated IDEs, okay? A lot of C or C++ programmers are basically hands-on people that want to have a terminal and a compiler, and you do command line and so on, very lean kind of programming programming methodology, if you want, okay? A lot of people, some people don't like to use an elaborated IDE, okay? So that's why you have, for example, GNU-CC, which is a command line compiler that you can use to compile your programs and eventually execute them. So depending on what kind of person you are, there's a lot of different possibilities, and one of them is to your liking. Again, in the lab, we'll advocate the use of Microsoft Visual C++, even though it's a very heavy kind of machine, right? So when you start it, if you don't have a very good machine, it's going to take a lot of time to execute it. And that's one of those things that some people don't like about heavy IDEs. myself included, I prefer to use command line, but I also, have to acquaint myself with these tools. So I came to understand or like somehow to use Microsoft Visual C++ or Eclipse. But I mostly use GNU-CC myself. It's more of a question of taste here, or also if you don't have the most updated computer, using Microsoft Visual Studio it can be painful. In terms of libraries, I told you that there's like literally thousands of libraries. We will not go in the direction of showing you how to use different libraries here. Rather, we will show you how to use the core C++ language to develop a reasonable size application. However, there are the standard libraries like the standard template library with the containers and so on. I'm going to give you one example of MFC when we talk about input and output, and you're going to see that even though libraries might seem to be, you might be tempted to use libraries, I'm going to actually show you that there is some downsides, the downside in using libraries sometimes. Not that we're going to require GUI for the development of the project and the assignments, but some people like to have a GUI even though it's not a requirement. Here are some links to some of the most popular and somehow easy to use, especially for SFML, very easy to use. Qt is an IDE, very heavy. Some people like it. People that like an IDE will like Qt. However, it's also very heavy and uses its own version of C++. So there's, advantages and also drawbacks to use specific solutions. Here's some, as I did in the first part of the lecture, here are some references. That's in no way a complete list of references. I try at the end of each of the slide sets to provide you with references that I used or referred to inside of the lectures. So that's about it for that. So that's it for this week. There's going to be another video about the presentation of the project, but that's not a video where or part of the lecture that's going to be presenting you some material. It's rather showing you, giving you some information about how we are going to do the project. So that's it for this slide set number 0. See you around.